Hello, welcome to Algebra, Chapter 2, Section 8, Probability and Odds. So, I always say whenever I teach probability and odds, this is one part of math you have to be careful with it. People can get addicted to gambling, so this is always mine. Don't get addicted to gambling. I know people who it's destroyed their lives, their marriages. Watch out for it. So, with that said, that's my little public service announcement. Let's learn what the difference in probability and odds. So you're used to these expressions being used in regular speech. Is it going to rain? Probably. What are the odds of me winning the lottery? None, because I don't play. But you hear these expressions in common speech, and in common speech they mean the same thing. But in math they're slightly different. So look in your book, if you're following along, on page 114, Probability and Odds. So the difference is probability is the number of favorable outcomes divided by the total outcomes. For example, I say to you, we're going to flip a coin. You call it in the air and you call heads. I always call tails, but you called heads. So if you were going to win, then there's one favorable outcome, heads. But there's two different things it could be. It could be heads or tails. So the probability is 1/2, or it's written like this, 1 to 2, or it could be written 0.5, because if you do 1 divided by 2 on your calculator, it's 0.5, or it could be written 50%, because if you change a decimal into a percent, you move the decimal place too. So the probability is 50% that things are going to work out for you. Now, odds are different. Odds are the number of favorable divided by the number of unfavorable. So if we were doing the same thing, then the number of favorable is there's one opportunity for heads, and the unfavorable is 1. There's 1 tails. So then our thing would be written that it's 1 to 1, and you hear it a lot, 50-50. It's 50-50. You know, that means you got as good a chance of things turning out the way you want as the way they don't. The way you don't want them to turn out. Okay? So that's the difference in probability and odds. In math, you usually do probability, but sometimes you talk about odds. And this is all part of a part of math called statistics, which really wasn't part of algebra when I took it. It was a part of pre-algebra, but not algebra. But now they've put more statistics in Algebra 1 and Algebra 2. Alright, so what if we were flipping 2 coins? What's the probability that both of them would be heads? Well, we have 4 situations. We could have heads, heads. We could have tails, tails. We could have this one be heads and that one be tails. Or we could have this one be tails and that one be heads. So those are our 4 situations of what the coins would do. So the favorable outcome is this one, and there's 1 favorable outcome. And unfavorable, the total number of outcomes, because it's probability, is there are 4 different scenarios. So the probability that they're both heads is 1/4, or you say 1 to 4. You read that 1 to 4. The colon is read 2, 1 to 4. Okay, so that was in your book, if you're following along, that was example 1A. 1B, it says an algebra class has 17 boys and 16 girls. And so that means altogether there's 33 kids. What's the probability if you selected a kid at random, an algebra student at random, that it's a girl? Well, so our favorable is there are 16 girls, and our total is 33. Did they reduce that or anything? No. So then you could do that on your calculator, and it was approximately equal to, it's not exactly equal, let me draw that again better. Approximately equal sign. An equal sign is straight like this. approximately you do two little wavy things like that. So they rounded it off. It's not the whole, it's not every number. It's approximately equal to, I think it said 0.4 what? 0.485. So less than 50%. All right? Okay, so let's try another one. Another thing is experimental probability. This is all theoretical probability. But experimental probability is based on experience or experiments, and you find out the answer that way. So if you look, like in your book on page 115, they surveyed a bunch of 500 teenagers, and they found out, asked them where they wanted to live, and 155 of them said they wanted to live in the city. So they did a survey, it was like an experiment, they found out the answers. The experimental probability is the number of favorable divided by total. Our favorable of living in a large city was 155. Our number of teens surveyed was 500. And then we could reduce that, or is it equal to or approximately equal to? It's equal to 0.31. So that was our probability. And probability is on the SAT, ACT. Now, I heard SAT is not going to be required in Georgia for a while. They're taking a break from that test. All right. Odds is favorable over unfavorable. So the next problem, example problem in the book is that you randomly choose a number from 0 to 9. What is the odds that you will choose a number that is greater than or equal to 4? That's the greater than or equal to. This is Pac-Man. He wants to eat the bigger thing, so it's x is greater than or equal to 4. Well, how many favorable do we have? We have 4, 5, 6, 7, 8, 9. So we have 6 favorable divided by unfavorable. So that's 0, 1, 2, 3. So our favorable to unfavorable, oh, wait a minute. 0, 1, 2, 3. That's 4. I can count. On my fingers, I can count. So 6 to 4, and if you have a fraction like this, you reduce it. So 2 goes into 6 3 times, 2 goes into 4 2 times. You would write it like that, or 3 to 2. So the odds are 3 to 2 that you would pick a number 4 or greater. All right, so the next one that is in our book is that if you have probability, you can figure out odds. And it's probability divided by 1 minus probability, and you can figure out what the odds would be from probability. So they said the probability that a randomly chosen household has a cat is 0.27. So almost a third of all people have a cat. And then they said, so what are the odds of having a cat? You write the probability up here, 1 minus the probability down here, and it is 27 over, you end up, you get 0.27 over 0.73, and if we change that, you know, to whole numbers, because it's a ratio, we're allowed to do that. We can say it's 27 to 73 is the odds the randomly chosen house would have a cat. And the other thing I didn't know about cats and dogs is, did you know that twice as many people have cats as dogs? From TV and the dog food aisle and all that, you would think twice as many people have dogs than cats, but it's the other way around. That twice as many people have cats than dogs. And then there's all the people who have both. I've had both before. I love all animals. But right now, I have 2 cats. And sort of a third outside the cow. Who's a wild cat that we just feed. All right. So this is probability and odds. Remember, don't get addicted to gambling. Gambling can be addictive. Watch out for it. And math is fun. See you later.